So, by now, most of you already know that 3I, ATLAS has officially raced past Mars and is now speeding toward the Sun at incredible velocity. This is the most intense part of its interstellar journey, and things are getting strange. It's releasing massive amounts of water vapor far earlier than any normal comet should, and its coma, the glowing envelope around it, is rich in carbon dioxide. In short, this thing isn't following the usual comet rules. With its closest solar approach, perihelion, just around the corner, astronomers all over the world have their telescopes locked in, eager to see what happens when sunlight and radiation begin to push this visitor to its limits. Let's break down the latest findings, why scientists are so fascinated by this strange traveler, and what might happen next. Discovery and background. The story began in July 2025, when astronomers using the Atlas survey in Hawaii spotted a small, fast-moving object with an orbit that didn't belong to our solar system. Its hyperbolic path, meaning it's not bound by the Sun's gravity, instantly marked it as the third confirmed interstellar object ever discovered, after Oumuamua in 2017 and 2I, Borisov in 2019. By early October, 3I, ATLAS crossed the orbital path of Mars, where the European ExoMars Trace gas orbiter captured distant images. Strangely, there was no clear tail, just a bright, compact coma, hinting that this comet wasn't behaving like the ones we usually see. Weird chemistry and early activity. Meanwhile, ground-based telescopes and the James Webb Space Telescope, JWST, teamed up for a detailed spectroscopic analysis. The results were stunning. 3I, ATLAS was venting water vapor at a rate of nearly 40 kilograms per second, while still nearly 3 astronomical units away from the Sun. That's an extreme level of activity, far too soon. Even more bizarre was the ratio of carbon dioxide to water, completely reversed from what we expect. Instead of water driving the outgassing, carbon dioxide dominates the process. It's basically the soda fizz comet of the cosmos. Polarimetric studies also revealed that its dust particles scatter light in unusual ways, suggesting either extremely fine grains or unique chemical makeup. And according to archived TESS, Transiting Exoplanet Survey satellite data, it was already active at 6 astronomical units from the Sun, a distance where most comets are still frozen solid. Such early activity means one thing. 3I, ATLAS likely formed in a much colder, chemically distinct region of a completely different star system, one that plays by its own rules. Possible explanations. Under normal conditions, water ice only begins to vaporize when a comet comes within about 3 astronomical units of the Sun. But 3I, ATLAS started waking up way earlier. The leading theory is that it contains super volatile compounds, like carbon monoxide or carbon dioxide, buried just below its surface. These materials are so heat-sensitive that even the faint warmth of deep space might be enough to make them sublimate, cracking the crust and releasing gas long before it should. Another idea is that its nucleus is extremely porous or fractured, allowing sunlight to penetrate deep inside and heat the interior more quickly. Either way, this comet is giving us a priceless window into how icy bodies form in other planetary systems. A visitor from a frozen world. A comet dominated by carbon dioxide means one clear thing. It was born in the deep, frozen outskirts of another star's protoplanetary disk, far colder than the region where our own comets formed. Even its polarization signature, how its dust interacts with polarized light, doesn't match anything we've seen from local comets. That could mean its dust grains are made of unfamiliar minerals or structured in ways we don't typically find here. Since dust grains preserve the chemical fingerprints of their home systems, scientists might actually use this data to infer what kind of environment 3I, ATLAS originally came from. Yes, some people have floated alien artifact ideas, a nod to theorists like Avi Loeb, But all the current evidence points toward a completely natural, though very exotic, origin. Approaching perihelion, the moment of truth now, here's where things truly start to get exciting. After months of tracking, 3I, Atlas is finally reaching the point of maximum tension in its long journey, perihelion, its closest approach to the Sun. On October 29, this alien traveler will swing to within 0.53 astronomical units, about half the distance between Earth and the Sun. That may not sound extreme, but for an icy body forged in the frozen outskirts of another star system, that's like being thrown into a cosmic furnace. The sunlight here is more than 4 times stronger than what it felt while passing Mars, and temperatures can easily soar above 500 degrees Celsius. This is the point of no return, and astronomers around the world are waiting to see how it handles the heat. Right now, 3 major possibilities are on the table. Option 1, a massive outburst. As the heat builds up, pressure beneath the surface could suddenly erupt, releasing jets of gas and dust. If that happens, 3I, ATLAS could flare up dramatically, brightening by several magnitudes and growing a spectacular tail visible even to small telescopes. Option 2, a breakup. The nucleus might simply be too fragile. If the internal stress becomes too great, it could fracture and disintegrate, like a frozen snowball cracking under intense heat. We've seen this happen before with comets that ventured too close to the Sun. If that occurs, 3I, ATLAS would vanish in a final burst of gas and dust, leaving only faint remnants drifting through space. And the third option, survival. The least likely but most fascinating outcome. If this interstellar visitor manages to hold itself together and glide past the Sun intact, it would defy expectations and give astronomers a chance to study something that's never been seen before: an interstellar comet after surviving a solar encounter. Whatever happens, it's going to teach us something new, not only about this single object but about the entire population of icy wanderers drifting between the stars. Watching the show to capture the event, the entire astronomical community has joined forces. The JUICE spacecraft, orbiting on the far side of the Sun, happens to be in a perfect position to watch the comet's aftermath from a unique angle. Because it's using a slower, backup antenna, the data won't reach Earth until early 2026, but scientists are confident it will provide rare insights into what happens when an interstellar body experiences its closest solar pass. Back on our side of the Sun, the James Webb Space Telescope and Hubble are already locked in, working together with dozens of ground-based observatories. They'll track every flicker of light, every chemical shift, and every change in brightness almost in real time. JUICE's infrared eyes will be especially crucial. By analyzing how sunlight reflects and what molecules absorb it, Webb can decode the composition of the comet's gases, mapping out which chemicals survive, which evaporate, and which new ones appear as the temperature climbs. If 3I, ATLAS does survive the fiery pass, astronomers expect it to reappear in early December 2025, gliding past Earth at a safe distance of about 270 million kilometers, roughly twice the Earth-Sun distance. That's close enough for our telescopes to capture stunning images, yet far enough to be completely harmless. That reappearance will be more than just a reunion. It'll give scientists a rare before and after comparison, revealing how solar heat transforms material that originated around another star. Why it matters: events like this are more than astronomical curiosities. They're natural experiments that reveal how matter behaves across the universe. Here's why 3I, ATLAS matters so much. It isn't just a random icy rock. It's a piece of another solar system, a chemical time capsule that has traveled for millions, maybe billions of years through interstellar space before arriving here. By studying it, astronomers can compare its chemistry, structure, and dust.